Good morning, student. Welcome back. Here we are going to discuss about the vapor compression cycle and classification of air conditioning system. As we have already discussed about the building services, basic fundamental of building services, or you can say the introduction of building services, and psychometric processes, psychometric chart, basic psychometric terms. Because if we want to study the HVAC system, then we should know about the basic fundamental of psychometry and vapor compression cycle, which we have studied in the RAC subject. But here is a simple glimpse of that basic fundamental, which is going to be used in further HVAC system. So in this regard, we are going to discuss the vapor compression, refrigeration cycle, and classification of air conditioning in today's lecture. So before going to in detail topic, let's first of all understand what is refrigerant and what is the refrigeration. When we talk about the refrigerant, it is nothing but it is the simple working fluid or simple substance which is used in a cycle just to transfer the heat from one place to another place. It is the substance or working fluid which is used to transfer the heat from one place to another place, or you can say it is the heat carrier. It takes it from one place and it rejects to another place. It is called the refrigerant. And refrigeration, it is the process just to lowering the temperature of by it is the process just to use the lowering the temperature by absorbing heat from the surrounding. When any operation, any process which is carried out just to absorb the heat from the surrounding to make the space is cold is called the refrigeration process, or simply you can say it is the cooling process by absorbing the heat from the space. Now the refrigeration process or the cooling process is carried out with the help of evaporation. It is very important phenomena which is called the evaporation or evaporative cooling, which is going to be discussed in the further slide in vapor compression cycle. Here let us understand how the refrigeration takes place with the help of evaporation, because it is very important to understand how the evaporation takes place and how it will help to reduce the temperature or how it will help to maintain the lower temperature. So you can see here in the slide, if the refrigerant in liquid state with very high vapor pressure is comes in contact with the surrounding, suppose a refrigerant with a very high vapor pressure in liquid state comes in contact with the surrounding, then this refrigerant will evaporates. It will get evaporated by absorbing heat from the surrounding. This refrigerant is comes in contact with the surrounding with a very high pressure refrigerant, and it will absorb the heat from the surrounding. Once it will absorb the heat from the surrounding, what will happen? It will evaporate. You can see in the slide, you can see in the animation here that when heat is absorbed in the refrigerant, then this refrigerant will get evaporated. The evaporation takes place that will result in the cooling of the surrounding, or the space will be cooled. This is simple called the refrigeration by evaporation, or you can say that the cooling with the help of evaporation. How we feel cool, how we get cooled with the help of evaporation, we can understand with the next example here. It's very simple phenomena and each and everyone can feel this phenomena, that the cooling with the help of evaporation. Suppose it is you can say it is your skin, and these are the this is the basically sweat gland, and these droplets you can see here, these droplets are the sweat droplets. Now when these droplets will get evaporated, we will feel comfortable or we will feel cold. Why? Because just to get evaporated, it required some amount of heat. It should absorb some heat, because without absorption of the heat, it will not evaporate. So it will absorb heat, and heat will be absorbed from where? The heat from the body. This small droplets of sweat will absorb heat from your body and it will evaporate it. You can see here the evaporation takes place. So once it is evaporated, your skin feel comfortable or your skin feel cold. So this is called the cooling with the help of evaporation. So I hope you understand what is the basic phenomena of evaporative cooling, how it is done. Now come to the next slide, which is major part of the lecture is vapor compression refrigeration system. Here, the word compression refrigeration means the cooling process or the refrigeration process is carried out with the help of certain compression phenomena. It means there must be some device just to make the compression in the system. So it is major thing is the compression is takes place in the cycle. That's why it is called the compression, and due to the result of compression in all process, the cooling is also provided. That's why it is called the simple compression refrigeration system. So first of all, let us understand what are the various components are used in this cycle, which is very important. All the refrigeration system, most of the refrigeration system are used nowadays as a vapor compression refrigeration system, as a main system. So here you can see the major four components are used in the cycle. The first one is the compressor, second one is the condenser, then expansion device, and the fourth one is evaporator. These four components are the major part. Now we will discuss about the what are the role of these four components, why they are used in the system, and how it works, and how it help to get the to just achieve the target of cooling, or you can say that how it will work, how it will help to achieve the refrigeration process in the cycle. So first of all, come to the part 1, which is the compressor. Very important. The major role of the compressor is two. The first role of the compressor is just to maintain the circulation of working fluid. Here the refrigeration cycle, in the refrigeration cycle, the refrigeration is circulating from one component to last component, and continuously this cycle is going on. And the main objective of the compressor is firstly just to maintain the circulation of the refrigerant, and second most important task by the compressor is to create pressure difference. So here are two major function of the compressor. The first one is to circulate the refrigerant in the cycle, and the second one is to create the pressure difference. And the second component, which is called the condenser, here is also two major role of the condenser. The first work of the condenser is just to release the heat from the refrigerant to the surrounding. It is the as we already discussed that the refrigerant is the heat carrier. It takes it from one place to another place. In this cycle, a refrigerant will reject the heat in the through condenser. So the first function of the condenser is to release the heat from refrigerant to the surrounding, and the second part is to change the phase of refrigerant. It changed from vapor to liquid state. It means the condensation process is also occurred in the condenser. So here are also two major work by the condenser in the cycle. The first one is to release the heat from the refrigerant to the surrounding, and the second one is to condense or to liquefy or to change the phase of the refrigerant from vapor to liquid state. So here are two functions which is done by the condenser in the cycle. And the third component is also very important, which is called the expansion device. As we know that the expansion means the reduction in pressure and increase in volume. So most of the time when we talk about the expansion, we will get some external work, we will get some work output, but here it is not the main objective to get the work output. So we don't need to install a turbine to expand the refrigerant to get the work output. Here we simply use the throttle valve or simple expansion valve just to reduce the pressure, so that we can get a chilled refrigerant or the lower temperature refrigerant. So the main function of the expansion valve is to reduce the pressure or to expand the refrigerant. And the fourth component is, as the name suggests, it is evaporator. Means the phenomena of evaporation will take place here in this component. It means when refrigerant will enter into the evaporator in liquid state, as we have already discussed in previous slide, that when refrigerant in liquid state with high vapor pressure will enter into the evaporator, what will happen? It will absorb heat from the surrounding, because it is low temperature refrigerant with high vapor pressure, and in liquid state when it enter into the evaporator, it will absorb heat from surrounding. Once the liquid refrigerant will absorb heat from surrounding, then what will happen with the refrigerant? Refrigerant will get evaporated. The evaporation takes place of the refrigerant, means refrigerant will evaporate. Once the refrigerant will evaporate, the result of the evaporation, you all know about the result of evaporation, that the cooling will be provided, means the space will be cooled. Once refrigerant is evaporated, it will be absorbed in the refrigerant. Then result of this phenomena, result of this operation is the cooling in the evaporator. So the in the evaporator you will get the cooling, means refrigeration occur in the evaporator by the evaporation of refrigerant. So how the system work? Simply you can see here, it is the compressor. When refrigerant is coming out from the evaporator, at point 1, the refrigerant will be in vapor state, because evaporation is done in the evaporator. So refrigerant will be in vapor state. Now vapor refrigerant will enter into compressor, and the role of compressor is to create the pressure difference. So now it will play his major role, that its major role, that it will increase the pressure, means refrigerant will be compressed in the compressor, and at point 2 it means the exit of the compressor, you will get high temperature high pressure refrigerant in vapor state. Means sometime or all the time it will be in superheated state, the refrigerant will be in superheated state, means it will be in vapor state with high temperature and high pressure. Now high temperature high pressure refrigerant will enter into the condenser. The next component is condenser, and the role of condenser is to reduce, or to release the heat from the refrigerant to the surrounding. Definitely it will release the heat, means you will get heat from here, heat is out, and the refrigerant will be condensed. So at point 3 you will get liquid refrigerant with high temperature high pressure. So here latent heat is released from the condenser, through the condenser from the refrigerant, and at point 3 you will get liquid refrigerant. So from 1 to 3 you will get the refrigerant will enter into the compressor, and it will be compressed at high temperature high pressure. Now the high temperature high pressure refrigerant will enter into condenser, and it will be condensed refrigerant at point 3, means high temperature high pressure refrigerant will be at point 3, which is the input or inlet of the expansion valve. Now this refrigerant will enter into the expansion, and here the expansion process takes place. Once the expansion is done, it means the pressure will be dropped. The pressure will be highly dropped. From high pressure to it will be at lower pressure. So resulting of the pressure drop, you will get some huge amount of reduction in temperature, huge temperature reduction. So once it is passing through the expansion wall, refrigerant will be chilled. Refrigerant at point 4, here you can see that at point 4 you will get a low temperature refrigerant in liquid state. When we talk about the practical vapor compression cycle, it's not possible that 100% refrigerant will be in liquid. Partially it will vaporize, 5% it will be vaporized, sometime it is 10% vaporized, but ideally we assume that 100% refrigerant will be in liquid state. We are discussing about the ideal vapor compression. We are not discussing about the practical vapor, because in case of practical vapor compression cycle there are slight difference. So just to make the things easy, we assume that it is ideal system. So after expansion you will get liquid refrigerant with very low temperature. Very low temperature means chill temperature will be there. Now this low temperature refrigerant with the low temperature refrigerant will enter into the evaporator. What will happen? Here the heat will be absorbed by the refrigerant, because low temperature refrigerant, if it is enter into the evaporator, then it will absorb heat from surrounding, that will result in evaporation of refrigerant, because refrigerant is in liquid state, and when it will absorb heat from the surrounding, it will get evaporated, it will be evaporated, definitely it will evaporated. And the result of the evaporation, you all know that there will be some cooling occur in the space from where heat is absorbed, from where heat is added to the refrigerant. Means a refrigerant is extracting heat from the surrounding, because it was the low temperature, then it will extract heat from the surrounding and the space become cool. Now at point 1, it is the exit of, you can see here, it is the exit of evaporator. At point 1 you will get evaporated or vapor state refrigerant with slightly high temperature. Slightly, it's not very elevated temperature, but the temperature will be slightly increased. So in case of evaporation process, you will get that the refrigerant will be evaporated. That will result in the change in temperature of surrounding, means temperature will be cooled. Now vapor refrigerant will enter into the compressor again and the cycle will continue. So this was the basic fundamental of vapor compression refrigeration system, how the refrigeration system is work. So here we are getting the cooling, here we are getting the refrigeration effect, which is called the evaporation, cooling by evaporation. Now in whole cycle, you can see it is the low pressure area, it is the high pressure area. So refrigerant is taking heat from this place and rejecting at this place. And here it is the TS curve. 1 to 2 is the isentropic, simply isentropic compression from 1 to 2, which is in compressor. And point 2 to 3 is the process of condensation. Here the heat will be released. At point 3 to 4 is the expansion process. You can see here it is the expansion process, and 4 to 1 is the evaporation process. So this was all about the simple vapor compression refrigeration system and how it is work. Now hope you understand this simple vapor compression system. It was the basic fundamental. Just to understand the further HVAC system, we should know about the basics, how the compressor and condenser, expansion, evaporator are work to make the system cool, or to make the system work. So it was the basic fundamental of the vapor compression. Now come to the classification of the air conditioning system. Here when we talk about the classification, means how the system are classified, how the air conditioning are classified, then there are certain parameters, because if there is no parameter, then we cannot classify the things. So here are 3 parameters on which the air conditioning system are classified. So first parameter is the application. When we talk about the application, when we talk about the application point of view, all the air conditioning in the world are classified in 2 categories. The first one is the comfort air conditioning, and the second one is industrial air conditioning. Comfort air conditioning means all the process, all the things are concerned with the human comfort factor. Means all the process which is carried out in the system, or the things we are providing in the comfort air conditioning is just to make the temperature comfortable. Means it should be the comfort range, and the humidity must be for the comfort range, velocity of air must be for the comfort range, and purity of the air. If we are concerning about these 4 factors for human comfort, then this category of air conditioning will be termed as comfort air conditioning. Apart from this, all the air conditioning will be known as industrial air conditioning, because if you are not concerned about this 4 factor of human comfort, then all the conditioning will be industrial air conditioning. For example, we can take an example of cold storage. There is also a vapor compression system, huge vapor compression system are installed in the cold storage, and that maintain the temperature from -10 to 8 degree, 12 degree, 14 degree. Although that is the refrigeration system, that is the air conditioning system, but that is not comfort, because there is a temperature -10 to 8, 10, 12. So that conditioning will be known as industrial air conditioning. And the second parameter on the classification is the season. If you talk about the conditioning on the basis of season, there might be winter air conditioner, there might be summer air conditioner, there might be year-round air conditioner. There are 3 class of air conditioning when we talk about the classification based on season: winter, summer, and year-round. And the third category is based on equipment. When we talk about the classification on the basis of equipments, then there are 2 categories of air conditioner. The first one is unitary and the second one is centralized. Either it will be unitary system, either or it will be a centralized system. What is unitary, what is in centralized? Let us understand. Suppose a building is required 100 TR of refrigeration system, or 100 TR of air conditioning system. Suppose a building is constructed and that require a 100 TR, 100 ton of air conditioning system. So we have two options. We can install one ton of AC into number of units is 100. We can install 100 number of units in the whole building. One. So it will be known as unitary, like window split and all. Such kind of air conditioning will be unitary. If you are installing in a units form, means 100 ton is required, then we will install 100 number of units, or 50 number of units, each of them is 2 ton. So it will be known as unitary air conditioning system. Apart from this, we can install a single 100 TR plant. We can install 100 TR of plant for the building, and cooling can be utilized, cooling can be circulated with the help of ducts and all the things. So this is called the centralized air conditioning. We have two options. We can install a single unit as a 100 TR, and we can install 100 units. Each one of them is 1 TR. So it is the basic difference of unitary and centralized. The basic example of unitary system is window and a split, like this. And centralized, in case of centralized air conditioning, there are VRV system, package air conditioner, and chilled water system. We will discuss in further lectures how the chilled water system work, how package air conditioner work, how VRV system works. So this was the basic classification of air conditioning. Hope you understand how the system are classified. So we are mainly concerned about the comfort air conditioning. We will discuss in further lectures only about the comfort air conditioning. We are not going to discuss about the industrial air conditioning because it is not included in the HVAC system, HVAC topic. So stay connected with the class. Soon we will be in next lecture. We'll discuss the remaining part of the system. So till then, take care.